since I was probably 13, and I'm 20 now, so it's like 7 years of just, I love it. Anyways, with that being said, what I want to do with my channel is make like science tutoring videos, mostly anatomy, because I'm going into nursing school and I just finished anatomy 1 and anatomy 2 and I really loved it, and I just want to like share knowledge with other people. And one thing that I really wanted to watch was ASMR anatomy videos, but I couldn't find any, so I was like, shit, I'm gonna make them. So that's what I'm doing. And honestly, I just want to start straight away with histology, because chapter 1 is an anatomical position, just the overview of anatomy, which is boring. Then we have the cell and chemistry, and it's all just boring. So we're gonna go into histology, which is also, and it's not my favorite, but it's important. It really is. So I'm gonna get straight into that. I'm just gonna take a sip of my water. And I don't even know where to start. I'm honestly like just going straight into this. I would love, oh god, this. Without further ado, I am going to be going over my histology notes. There are 4 types of tissues. Epithelial, which is skin and other things, but I associate it with skin a lot of the time. Connective, muscle, and nervous tissue. So that's the 4 main types. These all vary in structure and function of the cells and composition of the extracellular matrix, which is kind of a crazy word, but we'll get into it. From now on, when I say ECM, that means extracellular matrix. So ECM means the same thing. The ECM surrounds cells and can vary in texture from either liquid to a thick gel to solid, so it's very diverse. Some tissue cells are lightly packed with minimal ECM, for example epithelial tissue, and others the ECM is extensive. So getting more into the ECM, it provides tissues with strength to resist stretching and comprehensive forces. It directs cells to proper position within tissues. It regulates development, mitotic activity, and survival of cells in the tissue. And there are 2 main components to the ECM. It is ground substance and protein fibers. So, moving on to ground substance. Ground substance makes up most of the ECM. It contains water, nutrients, ions, and 3 types of macromolecules. So the first macromolecule is glycosaminoglycans. 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 Also known as GAGs, so I will be saying GAGs for the rest. It is large polysaccharides, which polysaccharides are chains of monomers of, see, I never know what word to use, but I like to think carbohydrates. So, but I'm pretty sure if you are studying anatomy, you know what a polysaccharide is. Anyways, they are negatively charged and hydrophilic, so they are not resistant to water. So imagine they just take up so much water. They're hydrophilic, they're not resisting water glycosaminoglycans. I just repeat that over and over again until it's ingrained. So that is part 1 of the ground substance. Part 2 of the ground substance is proteoglycans, which are gags linked to a protein to form an even larger molecule. So we just learned about gags. Proteoglycans include gags already, but it's just linked to a protein. It makes your ECM firmer, more solid, and more resistant to compression. It forms a barrier to diffusion of substances through the ECM and protects underlying tissue from microorganisms such as bacteria. So that was the second one. So just to go over 1 and 2 again. Gags draws in water by osmosis. Lots of water. Glycosaminoglycan. Proteoglycan is a gag connected to a protein, and we can think proteoglycan starts with a P. What else starts with a P? Protein. Good way to think about it. And the key association word with proteoglycan would probably be firm. So if you see the word firmness, it's going to be probably associated with proteoglycan. And then lastly we have glycoproteins, which are cell adhesion molecules. These are proteins with carbohydrates that hold everything in place and act as glue to bond cells and fibers to ground substance. So I would say definitely a key association word is glue, or to bond cells, to keep things together. And that is your glycoprotein. So those are the 3 parts of your ground substance, and ground substance is the first part of your ECM. Next we have the protein fibers, which is the second part of the ECM. These protein fibers are embedded within ground substance. There are 3 types of fibrous subunits with rope-like structures, and you'll probably recognize the names of them. We have collagen fibers, collagen fibers. We have reticular fibers and elastic fibers. And before I get into these, I am going to use the restroom, so I will be right back. So, collagen fibers. These are unbranched, cable-like, long protein fibers. They are strong, flexible, and resistant to stretching. This is the key word, or key phrase, resistant to stretching. It's 25% of the body's protein, and it is the color white in fresh tissue, and it is pink when stained under the microscope. Next we have reticular protein fibers. These are, these are thin, short collagen fibers. These form the meshwork or scaffold that supports cells and ground substances of many tissues. And the key association word for reticular fibers is that it's web-like. So think a spider web. And this helps trap things. So the spleen, for example, is made up of reticular protein fibers, so it can trap the foreign cells to help in your immune system. So, and then thirdly we have the elastic fibers. These contain the protein elastin. Duh. They branch and rejoin and appear very wavy. They stretch and recoil easily, so that means they are stretchier than collagen. And these are located in the skin, arteries, and veins, or arteries and veins and lungs, because you need a lot of stretch. You need a lot of stretch in your skin to do things, in your lungs to breathe, and you need stretch in your arteries for when your blood pressure goes up, nuclei is still attached to the basement membrane, and so is the ciliare that is pseudostratified. It's just a little bit wonky and wavy. Next page. Squamous are described as flat, wide, and a little irregular cells. Cuboidal cells are cubical. The nucleus is round and located in the center of the cell. And then we have columnar, which is tall. The nucleus is oval shaped, and I was gonna say something else, but then I was like, no, that's pretty much it. Columnar cells are tall, skinny, and the nucleus is a little bit oval shaped, while the cuboidal cell, its nucleus is more round. So, simple squamous provides a barrier which gases and fluids can be exchanged, and it is located in the air sacs of lungs, inner lining of ventral body cavities, and blood vessels, and then certain parts of the kidney. My phone keeps wanting to die. It's on 20% right now, but it's okay, we'll get through it. Simple cuboidal is in charge of absorption and secretion of mucus and other substances. It is located in the kidney tubules, lower respiratory passages, and the thyroid, salivary, and mammary glands. The simple columnar epithelium is in charge of absorption, secretion of mucus and other substances. It propulses the egg through the uterine tube. It is part of the digestive tract from the stomach to the anus, and it is also part of some kidney tubules. And then there is pseudostratified columnar epithelium, also known as PCCE. It secretes mucus and propels it with ciliary motion. It has little cilia on top. It is located in your nasal cavity, parts of the male urethra, and the upper respiratory passages, because when we're trying to cough up stuff, we need that cilia to push it up. And that's why when you smoke cigarettes, it paralyzes the cilia, and you just get all sorts of gunk in there because your cilia can't really move. It's paralyzed from the nicotine. Alright, so I have some notes about cellular transport, but that's too much. And then I'm going to go over the stratified epithelium. So we have keratinized stratified squamous. The apical cells are dead, flaky, and filled with keratin. It protects from mechanical stresses and prevents water loss. So we have keratinized stratified squamous in our skin because we don't want to lose that water and hydration. So yeah, it is part of the epidermis. Then we have non-keratinized stratified squamous. The apical cells are living and very flat, and these cells are more cuboidal towards the basement membrane. Protection from mechanical stresses. It's located in the mouth, pharynx, superior larynx, esophagus, and the vagina and anal canal. Then we have stratified cuboidal, which is in charge of some absorption and secretion, and it's in the ducts of your sweat glands. Then we have stratified columnar, which is part of protection, some absorption and secretion, and the ducts of certain glands, and it's also part of the male urethra. And finally, we have transitional epithelium. The apical cells are dome-shaped; they kind of look like bubbles, and it adds an extra stretch to your cells or your tissues. So this is located only in the urinary bladder, ureter, and urethra, because you need that stretch. Next, we are going to go into glandular epithelium. A gland is an epithelial structure. It synthesizes and secretes products from designated secretory cells. It can be unicellular, which is called a goblet cell, or multicellular, which classified by either the shape or how products are released. There's endocrine, which secretes products into the bloodstream, and it causes systemic effects. And then you have exocrine, which release products onto apical surfaces, also known as ducts, of epithelium or lining hollow organ. These only have local effects on glands in the vicinity, and they vary in complexity. The unicellular exocrine glands, aka goblet cells, are the most common unicellular exocrine gland, and they are part of digestive and respiratory tracts, and they secrete mucus. The multicellular exocrine glands, which is most of them actually, they're classified by the duct structure and the shape of clusters in the secretory. Simple glands are ducts that don't branch, and compound glands are ducts that do branch. Shapes of clusters include tubular, which are long and straight. There are acinar or acinar, which are spherical. And then there's tubular acinar or tubular acinar, which is a combination of the two. Someone flushed the toilet. And we're almost to the end of epithelial tissue, and I'll probably end the video here because I realized I think I'm gonna just do subsets of each thing because I don't want to make an hour-long video. I'm going into the methods of product secretion. We have merocrine. This is used by a majority of the exocrine glands. Products packaged into vesicles for release by exocytosis into ducts. An example, production of saliva and sweat by salivary and sweat glands. That was merocrine. Next we have holocrine. Secretory cells accumulate product in cytosol. Product is released when the cell ruptures and dies. Cells replaced by mitosis at gland base. An example is the production of sebum by sebaceous glands. And then next we have apocrine. It is a rare type of secretion. Portions of cytoplasm are pinched off, with product being secreted. Observed during lipid droplet secretion in lactating mammary glands of many mammal species. Next we are going into, and lastly we are going into carcinogens and epithelial tissue. Carcinogens are agents that induce DNA changes and can lead to cancer. Carcinoma is epithelial cancer. There is pre-malignant cancer cells that produce enzymes that degrade the basement membrane, which facilitates the spread of the cancer. And that is the end of my notes for epithelial tissue. In the next video, I'll go over connective tissue. I'm just gonna briefly look to see if I have anything else about epithelial tissue before I go ahead and cut this short. No, that's it. So, very excited. I will get into connective tissue in the next video, and hopefully I like how this turns out because, again, this is my first ASMR video. Other